Welcome to you all. Standard 10th Mathematics, Unit 1, Relations and Function. So, the previous class we have finished relations. Today we are going to learn functions. So, functions. Definition. A relation f between two non-empty sets x and y is called a function from x to y if for each x belongs to capital X, there exists only one y belongs to y such that xy belongs to f. So, only one exists, that is very important. That is f equal to set of x comma y such that for all x belongs to capital X, y belongs to capital Y. A function is also called as a mapping or transformation. So, its other name of the function is mapping or transformation. So, functions are subsets of relations and relations are subsets of Cartesian product. Already we have in the first class we have studied Cartesian product. So, we know what is that, A cross B. So, then we have studied relation. So, here function. So, here says functions are the subsets of relations. See this picture. So, function is inside of the relation and the relation is inside of the Cartesian product. So, we can say functions are subsets of relations and relations are subsets of Cartesian product. If such that x is to y is a function, then the set x is called the domain of the function f and the set y is called its codomain. So, this is domain and set B is codomain. Domain and the codomain. So, these all elements are domain. So, set of 1, 2, 3, 4, 5 is called domain. Set of A, B, C, D, E is called codomain. If f of A equal to B, then B is called image of under F and A is called a pre-image of B. So, this A is called pre-image. Here this B is called image. So, already we have studied range also. So, this is called pre-image, this is called image. So, these are the elements domain, these are the elements codomain. The set of all images of the elements x under F is called the range of F. So, already we have studied the range. Once again we will see it today also. So, if such that x is to y is a function only if every element in the domain of F has an image. The image is unique. The image is unique. So, that means so each of the input has one output. So, that is unique. The image is unique. So, testing for functions. So, what is function? What is not a function? Now, that we are going to see. See here for the first picture, set x. Set x has the elements. These are called input also, A, B, C. So, these are the output 1, 2, 3. So, we can see this input has each output. See. So, when you see like this is a function. So, each input has each output. So, that is a function. Here the second picture you can see each input has a output, but the output is same element. So, that is also a function. But you see here one. So, each input has the output. So, that is the function. This next picture will let us see. So, A has the input A has the output 1, B has the output 2, but C has no output. So, we can say it is not a function. It is not a function. In this picture we can say A has 2 output. So, that also not a function. So, if you see input has 2 or 3 output, that is not a function. Okay, now from our book we can see. See here. So, the same picture they have given A, B, C, set of A, B, C, here P, Q, R. This represents a function. So already I told you, each input corresponds to a single output. So each input corresponds to a single output. Here also, so each input corresponds to a single output, you see. So n has the 2, so output has the two input maybe, but each input corresponded to a single output, that is the function. But here this is not a function, because one of the input B is associated with 2 outputs, so it is not a function. So I hope you understand. Now, so with this we can start example 1.6. Let x equal to set of 1, 2, 3, 4 and y equal to set of 2, 4, 6, 8, 10 and capital R equal to set of 1, 2, 2, 4, 3, 6, 4, 8. Show that R is a function and find its domain, codomain and range. So now we are going to see everything here. So for that we must know the, so I have drawn here the x, set x here 1, 2, 3, 4 and set y 2, 4, 6, 8. Now the R 1, 2. So now we are going to join with 1 and 2. So we are going to join. See here, 1 and 2 has to be joined. The same way 2 and 4 has to be joined. 2 and 4. Two and 4 has to be joined, and 3 and 6 has to be joined. 3 and 6 and 4, 8. 4, 8. So 1 and 2, 2 and 4, 3 and 6 and 4, 8. So these are the things. So we joined. Now see, each input is associated with each output. So we can say, surely we can say R is a function. R is a function. So now domain x. We are going to write what is domain. These are the domain. These are the codomain. So both are we are going to write. So here 1, 2, 3, 4 domain. So we can say 1, 2, 3, 4. So these are the domain. Now we are going to write codomain. What is that? 2, 4, 6, 8, 10. So codomain 2, 4, 6, 8, 10. So these are the codomain. Now the range. So what is range? Already we have studied. So these are output. This output is called the range. So only 2, 4, 6, 8. Why we don't have 10? Because there is no number elements is associated with 10. So we can write it 2, 4, 6, 8. So these are the range. So in this problem we have seen whether R is a function and domain, codomain and the range. So the 1.6 is over. Now example 1.7. Now example 1.7. A relation f is defined by f of x equal to x squared minus 2, where x belongs to minus 2, minus 1, 0, 3. List the elements of f, and is f a function? So there are two questions. First question, f of x equal to x squared minus 2, where x belongs to minus 2, minus 1, 0, 3. So here we can see minus 2 the whole square. So x, the x value, so they have given minus 2, minus 1, minus 2, minus 1, 0, 3. Minus 2, minus 1, 0, 3. So these values we are going to use here. F of minus 2 equal to minus 2 square minus 2. So 4, minus 2 into minus 2, we know it 4. Minus into minus plus 2 2s are 4. So 4 minus 2, 2. Here minus 1 squared. Minus 1 squared, we know it, minus into minus plus 1 into 1 is 1. So we can write it here 1 minus 2. So we get the answer minus 1. So we get the answer minus 1. The same way f of 0. F of 0, so what are the power may be? 0 power 2, 0 power 3, so whatever may be, we get the answer 0. So 0 minus 2. So we get the answer minus 2. We get the answer minus 2. Now f of 3. So x squared, 3 squared, 3 3s are 9. 3 3s are 9 minus 2. That is equal to, we get the answer 7. See, we have to write the f elements. So f equal to set of, so here minus 2. You can see this. This also minus 2. And this one minus 1. Here minus 1. So minus 2, 2 here, 2 here. The same way minus 1 is here, minus 1 and the minus 1. And 0 minus 2. Here see 0 and here minus 2. So here also 0 minus 2. And here 3 and so the last element is 3 and 7. So I hope you understood. So this is f. Now is f a function? So the same elements I have put it in the Venn diagram. See here, these are the elements, minus 2, minus 1, 0, these 3. These 3 are input. These 2, minus 1, minus 2, 7s are output. So I have written here input minus 2, minus 1, 0, 3, minus 2, minus 1, 0, 3 here, and I have written 2, 1, minus 1, minus 2, 7. 2, minus 1, minus 2, 7. So just to explain you, I have put this Venn diagram. It's a function. We are going to see this. So minus 2 joined with the 2. So minus 2 joined with the 2. See, joined with the 2. And minus 1 joined with the minus 1. Minus 1 joined with the minus 1. And 0 joined with the minus 2. And 3, 7. 3, 7. So each input out associated with this output. So each element in the domain of f has unique image. So f is a function. So f is a function. So I hope you understood everything. Thank you.